Hello everyone, and I hope that you're doing great today. Now, today we're looking at angles of inclines, and what I'm going to do is to run through some basic concepts by taking you back through your mathematics class. The first concept, we're looking at angles in a triangle. And so remember that the total angle in a triangle equals to 180 degrees. Therefore, the total angle, which is 180 degrees, equals to 90 plus theta 1 plus theta 2. The next concept, we're looking at angles on a straight line. And remember that the total angle on a straight line equals to 180 degrees as well. Therefore, the total angle, which is 180 degrees, equal to theta 1 plus theta 2. Another point to note is that we're looking at angles on intersecting lines, and vertically opposite angles on intersecting lines are equal. So therefore, theta 1 and theta 2, they are vertically opposite. Theta 3 and theta 4, they are vertically opposite. So point to remember is that theta 1 equals to theta 2, theta 3 equal to theta 4. If you look carefully on this diagram, you will also notice that the total angle is also equal to 360 degrees. So therefore, theta 1 plus theta 2 plus theta 3 plus theta 4 all adds up to 360 degrees. On the quick concept here, we're looking at corresponding and alternate angles, and they are all equal. So therefore, for intersecting lines, corresponding and alternate angles are equal. All right, we have the first four angles already labeled, 1, 2, 3, and 4. So let us put the other angles, which is theta 5, theta 6, theta 7, and theta 8. Now, what we're going to do is to categorize these angles into three groups. We're going to categorize them in corresponding angles, alternate interior angles, and alternate exterior angles. For the corresponding angles, those are the angles that are pretty much in the similar position. So they are relatively in the same position on the different parallel lines. So if you take theta 1, for example, it corresponds to theta 5. So notice they are pretty much on the same position on the opposite lines or the two parallel lines. All right, and so if you go to theta 2, it will be pretty much on the relatively same position as theta 6. So theta 2 and theta 6, they are corresponding. Therefore, theta 3 is corresponding to theta 7, and theta 4 is corresponding to theta 8. All right, so notice they are on similar positions. Now, for the interior angles that are alternate, we're talking about between the parallel lines, so we call them interior angles. And so if you look carefully, an alternate, by the way, is one after the other. So if you look at angle 3 or theta 3, the one that you skip one technically and go to the other, so that's alternating. And so we will have here theta 3 and theta 5, they are equal. So they are alternate to each other. And if you go to theta 4, it is alternate to theta 6. All right, for the exterior angles, those are the angles on the outside of the parallel lines. All right, and so let's look at the alternate exterior angles. And so theta 1 and theta 7, they are alternate angles. All right, and if you look at theta 2, it is alternate to theta 8 on the outside of the parallel line. So those are the alternate exterior angles. All right, so from this, we should be able to answer most or identify most of our angles on an incline. All right, so the next thing we'll look at here is just to quickly remind you that all the angles in green, they are equal, and all the angles in pink are equal. All right, so you can take your time and look at it carefully, all right, and revisit this section. Jumping on to another point is that for a Z angle, alternate angles on Z are also equal. So if you notice here, the 3 and 5, they are equal. The 4 and the 6, they are also equal. All right. So now let's look at our incline from all of this. And firstly, what we want to do is to really put on our forces. So we'll quickly do that. So we have our force diagram. And so let's label quickly so we have a better understanding of this. So we have our perpendicular force, which is the normal, and the normal acts perpendicular to the incline upwards. All right. And we also have a perpendicular force going down as well, which is equal to the normal as well. All right. And that is below the incline. We have our weight, and our weight is calculated as mg. And a point to note that the angle of the weight from the perpendicular force is also equal to the angle of the incline from the horizontal or from the ground. All right. Next, we have our applied force. And the applied force is a force that caused the object to accelerate down the incline. Opposing the applied force, we have our frictional force. All right. And again, depending on the question of the incline, you can have a frictionless incline or a rough surface incline. All right. So it all depending on your question, whether or not you will have a frictional force or not. But not withstanding that, however, we want to actually identify our angle. So what I'm going to do is to remove the object, and we have only our force lines. All right. Now, a point to note is that the applied force and the frictional force, they are parallel forces to the incline. So what we can do is to draw a parallel line below the incline to make it be nice and easy to understand. All right. And so now we can start looking at all the angles separately. All right. So point to note again, the normal force is perpendicular to the incline. So it is at 90 degrees. And if that is 90 degrees, then we can say that the perpendicular force below the incline is also 90 degrees to the parallel line, or we call it the parallel force. All right. Now we form our Z shape. And again, remember that alternate angles on Z are equal. But before we go to that, a point to note here is that this angle will be 90 minus theta, because the total angle within this triangular section is equal to 180. All right. Now, once we have that, we can identify this angle right here, because again, this angle is alternate to this angle. So they are all equal. Okay. So these two angles are equal. Or better yet, you can say this section here is 90. So therefore, theta from 90 give you this angle. All right. In the same breath, we can talk about alternate angles as well. All right. So what we're going to do now is to form our triangle section right here and can analyze this triangle, which is going to be very important in terms of answering most of your incline questions. And so let us take this triangle out. And I want you to note before I move on is that this line right here, this is your parallel line to the incline, which is also called the horizontal. All right. This line right here is your perpendicular force. All right. And that is equal to the normal force. All right, so what we're going to do is to flip this triangle around to make life a little bit easier. And so once we have this flip, what we have here, we have the angle of the incline at the bottom right here. And again, because the triangle is flipped, remember that this vertical line is actually the horizontal line, only because it is flipped. All right. And so this horizontal line right here is the y. So even though it is showing horizontal because the triangle is flipped, it is still your y. And since it is adjacent to the angle, it is mg cos theta. All right, and mg is your hypotenuse. So the other line, which is our vertical line shown right here, which is actually our parallel line, which is x, it is given as mg sine theta. It is sine because this side is opposite to the angle of the incline. All right. And so once we have that, we should be good in answering most of your incline question. And so I want to thank you for watching this lesson. And I want to remind you that the best angle from which to approach any problem is the triangle. Do you get it? Triangle. Keep trying. No matter what the problem is, just keep trying, keep going. All right. So have a wonderful and blessed day, and I will surely see you soon. Take care.